Hi, welcome back to class. Common expressions in mathematics are probably when you are expanding x plus y all raised to power 2. You can easily expand this into x plus y into x plus y. Now it becomes a little bit challenging probably when I have x plus y raised to probably the power of 64. Now, when you have such things like this brings us to binomial expansion. You can easily use binomial expansion to expand things like this. But for today, we'll be starting binomial expansion with Pascal's triangle. I'll introduce you to the concept of Pascal's triangle and how you can use it to expand simple expansion. Let's get started with an example. Now, my first example is probably if I have x plus y raised to power 3. Let's see how to raise this. Now, let's create Pascal's triangle. Now, Pascal's triangle says if I have 1, I'll be building the coefficients for my solution from Pascal's triangle. Please just follow me gradually. 1, then the next line will give me 1, 1. The next line here will be 1. 1 plus 1 will be 2. Then here I'll have 1. The next line here I have 1. 1 plus 2 is 3. 1 plus 2 here is 3. Then I have 1. Now I have 1 again. 1 plus 3 here will be 4. 3 plus 3 here is 6. 3 plus 3 here is 4. Then I have 1. I have 1 again. 1 plus 4 here is 5. 4 plus 6 is 10. Sorry, that's 10. 6 plus 4 again is 10. Then 4 plus 1 is 5. Then I have 1. Now, if you look at these coefficients, these are the coefficients for my solution. So this is the coefficient when it is raised to power 0. This is the coefficient when it is raised to power 1. These are the coefficients when it is raised to power 2. Here's the coefficient when it is raised to power 3. Here's the coefficient when it is raised to power 4. Here's the coefficient when it is raised to power 5. And I can continue down the series. Now, let's see how I use it with the coefficients. Take, for example, if I have x plus y into bracket raised to power 0. Obviously, we all know that anything raised to the power of 0 is 1. Now, if I have x plus y in the bracket all raised to the power of 1. Now, here, my first sum here, my first item here is x. Now, I'm going to, the coefficient here from this line here, if you look at 1 and 1, that means I have just 2 items. That will be 1, that's the first coefficient. X will be raised to the power of 1 because the highest power I have here is 1. Then y will be raised to the power of what? 0. Plus 1 again. X will be raised to the power of 0 now, while y will be raised to the power of what? 1. So that expansion is the same thing as x plus y. Why? Because y raised to power 0 here becomes 1, and x raised to power 0 here becomes what? 1. Now let's look at x plus y, now raised to the power of 2. That becomes x now, that becomes, if you look at the line of 2 from my Pascal's triangle, I have 1, I have 2, and I have 1. I have just 3 coefficients. So my first coefficient here is 1. That will be x now is raised to power 2. When the power of x is reducing, the power of y is increasing. Now, y now will be raised to the power of what? 0. Plus 2, I'll have x raised to the power of 1. X now is reducing. Now, y will be raised to the power of what? 1. Plus 1 again. X now will be raised to the power of 0, while y will be raised to the power of what? Of 2. So that my expansion, if you expand this, you come up with x squared. Now, y raised to the power 0 here becomes 1 times x squared is x squared plus 2xy plus x raised to the power 0 is 1 y squared. You see that is the same expression with what you have gotten if you had expanded this. Now, let's now solve for our x plus y raised to the power of 3. Now, to solve for x plus y raised to the power 3, we pick the third line. That's the third row here. This is where I will solve for x plus y raised to the power of 3. Now, my first coefficient here will be 1. I'll have x. X is going to be raised to the power of 3. while y will be raised to the power of what? 0, plus, now I have 3, x now will be raised to the power of 2 is reducing, while y will increase, raised to the power of 1, plus, I'll have 3 again. If you look at it, this is a third. I have 3 again. X now will be raised to the power of 1. X is reducing, while y will be raised to the power of 2. Now, plus, I now have 1. X will be raised to the power of 0, while y will be raised to the power of what? Of 3. So, finally, this will look like 1 times x raised to the power 3. That's x raised to the power 3 plus x 3 x raised to the power 2 y plus 3 x now, y will be raised to the power of what? Of 2 plus y raised to the power of 3. So that's the result of expanding this sum. Now let's take an example. We'll take this example. Our example says we are using Pascal's triangle to expand 2x plus 3 raised to power 4. Now let me go back to my Pascal's triangle to get my coefficient. Now from my Pascal's triangle here, you can see that my coefficient is 1, 4, 6, 4. Let's write that out. I don't want to repeat the Pascal's triangle. That's 1, 4, 6, 4, and 1. Now, so if I'm expanding, sorry, my pen, I'm expanding 2x plus 3y all raised to power 4. Now, this will look like, this becomes, my 2x is the first item, while my second item is the 3y. Now, the first coefficient here is 1. Now, my 2x will be raised to the power of 4. While my 3y is raised to the power of 0. That's 1. So, let's leave that out. Plus, now the next coefficient is 4. My 2x will reduce, will be raised to the power of 3. While my 3y will be raised to the power of 1. Plus 6. Now, that's the next coefficient. My 3y now will be raised to the power of, my 2x will be raised to the power of 2, while my 3y will be raised to the power of 2. While x is increasing, my y side is what? While x is reducing, my y side is increasing. Plus 4 now into my 2x now will be raised to the power of 1, while my 3y will be raised to the power of 3. Now finally, plus 1 is the last coefficient. My 2x is raised to power 0, which is already 1, times my 3y will now be raised to the power of, my 3y will be raised to the power of 4. So that this is now the same thing as 2x raised to power 4, that's 2 raised to power 4, that's 2 times 2 times 2, that's 16. That's 16x raised to power 4 plus my 4, now 4 into 2x, that's 2x raised to power 3, that's 8x raised to power 3 into 3y, let's leave it like at that, into 3y, we'll expand everything later, plus 6 now into 2x raised to power 4 raised to power 2, that's 4 x raised to power 2 plus 3 raised to power 2, that's 9, okay, times, sorry, multiplied by 3y raised to power 2. Now plus 4 into 2x, that's 2x, times 3 raised to power 3, that's 27. 27y raised to power 3, everything now plus 9, no, 2, that's 3. 3 raised to power 4, that's not 9. That's 9 times 9, that's 81. 3 raised to power 4, if you use your calculator, that's 81. And y raised to power 4. Now we can expand this finally to give us 16. We'll come up with 16x raised to power 4 plus 4, 8 times 3. 8 times 3, that's 24 from my calculator. 8 times 3, that's 24. 8 times 3, that's 24. 24 times 4, that's 96. This becomes 96 x raised to power 3 times y plus 6 times 4, that's 24, times 9, that's 216. 216 x raised to power 2, y raised to power 2. Now plus, sorry, let me just demarcate this to differentiate it. Plus, we have 4 times 2 times 27 equals another 216. That's 216 x raised to power 1, y raised to power 3. Now plus 81 y raised to power 4. Now you see that the Pascal's triangle makes expansion easier. It makes it easier instead of being too cumbersome. With this lesson, I hope you understand how to use the Pascal's triangle to expand your sums. Now, in our next lesson, we'll be looking at more questions on how to apply the Pascal's triangle. If you are yet to subscribe to our channel, please do not hesitate to hit the subscribe button and the notification bell. That way you'll be notified when we create sums like this. In our next lesson, watch out for how I use the Pascal's triangle to solve a sum. Thank you and see you in our next class.